Welcome to a quick tutorial on the line AB component. This is part of the Grasshopper component glossary, and we'll go over just a couple ways to use this component that creates a line out of 2 points. Please don't forget to like this video if you think it's worthwhile, and subscribe to the channel if you'd like to see more. Anyway, let's get right to the component we're exploring. I'll double click on the canvas and type line, and it's this one with 2 points at the end of a black line, and it says A and B, and so that's where you plug in your points, so I can get a point component. And let's say set multiple points, one there, and then if I say dispatch and plug A and B, or either way, in there, then it's going to make a line. This is one of the most straightforward components, a very easy one to understand. So let's use it in a few different ways. This component, and actually probably most components, are used much more often with lists and data trees of geometry rather than just single geometry. So let's get a simple list of points. Let's start by making a simple spiral. I'm just going to make a series component, and first I'm going to divide one by anywhere from 10 to like 300, we'll say. And this is going to be a step in our series component. So what we're doing now is getting a series of numbers, and each consecutive number will increase by this amount. Right now it's increasing by amount of 10 divided by 1, which is 0.1. And so if we get a panel, we can see that we're just increasing by 1 until we get to 0.9. That's where the count comes in. Let's get a count anywhere from 10 to 300 also. Let's go to like 39 or so. And I'm going to get a circle. So to make the spiral, I'm just going to get a bunch of points that are somewhere on this circle. And each consecutive point, I'm going to raise in the z direction a little bit. And then I'm going to connect all those points. So to get different points on the circle, we have a curve coming out here. We can get evaluate curve component. It's this one here, evaluate curve. I'm going to right click and go to reparameterize. That way we only need parameters between 0 and 1 to get every point on this curve. And we have a series that's going well beyond 1. To get a repeating series, something that's always going between 0 and 1, but in equal increments, every time we get over 1, we want to go back to 0, essentially. We're going to write a quick script using C#. So I'm going to type in C#. It's really good to get comfortable writing some code, but if you really don't want to do that right now, you can skip ahead a little bit. We'll be doing something completely new in about 5 minutes. So back on our C# component, let's get rid of this Y input by just clicking the minus sign next to it. Then I'm going to right click here and go to type hint double. These are going to be our inputs. And this is a very short script that's going to be inside here, so I'll double click here. And all I need to write in here, we don't need this little green spot. We don't need this green text here, so I'm going to delete that. And instead I'm going to write double y equals x. So that's going to say everything that comes in as x into our input is going to be stored in this variable called y. And then I'm going to make a while loop, something called a while loop. I'm going to say while and then parentheses. And inside the parentheses, I'm going to say y is greater than 1. So what this is saying is every time we see a y that's greater than 1, we want to say y minus equals 1. So, for example, if x comes in as 1.5, then y is going to be 1.5. And so then down here, we're going to ask, is y greater than 1? 1.5 is greater than 1, so this statement is true. And then we're going to say, take 1.5 and subtract 1, and then put that value back into y. So 1.5 minus 1 is 0.5, and so now the variable y doesn't hold 1.5, it holds 0.5. But if it was still greater than 1, then we would keep going, like if we had started with 3.3. Then we would subtract 1 to 2.3, which is still greater than 1, subtract 1 to 1.3, still greater than 1, subtract 1 to 0.3. And then the while loop would stop. And so then we'll set our output A to Y. So whatever's in Y will be coming out of the output that's labeled A. So that's all we need for that. Yes, I want to save it. And then these are going to be our parameters. So now we have a bunch of points on this circle. Let's deconstruct these points, which just means get the x, y, and v coordinates, and then we can reconstruct some points. We can say construct point, and the x and y's are exactly what we want, but we want the z's to be a little bit different. We want the z values to go up each time we're going around the circle. I'm going to hide this. So to go up each time, let's get a multiplication. And we'll say 0.000 is less than like 5. So these numbers are continuing to go up and up and up. So let's multiply these by some number. And let's let that be our z values. Then we can hide all this, and let's get an interpolate. This one here, this just takes in a list of points, and it approximates a curve, and that curve is always meeting each point. So now we have a spiral. We can make the distance between these a little higher, and we don't need as many, we don't need to go as high. That's fine, just a little spiral like that. Now let's rotate this spiral by an amount of pi, which is just halfway around a circle. Let's hide both of these and merge them into one component. So now these are in a list together. And to use the line AB component again, let's divide these curves. We'll say divide curve, and it's going to be this one. These are going to be our curves to divide. And then we can get a number between like 10 and 100. And let's type in bang, and this little component called explode tree will come up. If we put that in, then it's going to separate these two branches. So we got one branch of points coming from one curve and another branch of points coming from the other curve. If we use this bang component, then we have them separated, and we can say line, and get this line AB again, and we can make some lines between these. So we can hide these points, and let's make a pipe to make these curves a little bit bigger. We don't want them to be that big though. I just got a number slider between 0.001 and 1. It's probably big enough. Let's go to the front view and let's get a custom preview. So this is a component that you can put materials on geometry. So let's put that in as our geometry, and I'm going to type in color and grab this component called color swatch. Let's get like a copy these. So I just selected these. I'm going to type Alt to copy them. Turn that preview off. And we can change the shape of this. So that's another way that we can use line AB. We can also use it to make surfaces. Let's hide all this and start something new. I'll go back into perspective. And let's get another circle, but this time let's put it on the YZ axis. So I'm going to type in circle again, and there's our circle. But this time let's type in YZ, and we'll put that in as our plane. So now we have a circle in the other direction. And then let's get a move component. We're going to move this in the x direction, both 1 and -1. So I'm going to get a negative component. And I'll say 1.000. And then let's get a unit x vector. So I want two vectors in here. I want a vector pointing in the x direction 1 and one pointing in the x direction -1. Right now we have -1, but if I hold shift and put this in there, then we have 1 and -1. And these are going to be our move vectors in this move component. So now we're going to move that circle in either direction. We can hide all of this. Now we're going to get a seam component. And let's reparameterize this. What this component is doing is changing where the start and the end points for this circle are. So right now, if I just put 0 in, and let's say, actually let's not put it in there, let's get an evaluate curve component, and reparameterize this. Let's put 0 in there. That's where the circle starts and ends. So it starts and goes all the way around, and then it ends there. If this seam component will change where that seam is. So let's get a merge component, and let's get two sliders between 0.000 and 1. So now we can change where one of these seams are, or both of them. So we don't need this anymore, but let's get in a divide curve again. And Let's get a slider between 10 and 100. You can keep these. And then again, let's get that bang component. That's called explode tree. And then we can get line AB. And so now, if we change one of these seams, then we get an interesting shape. Let's increase the number of divisions here, and let's look at the front view. So this is called a hyperboloid, this surface here, or the surface that these lines would make. Let's actually change how we're viewing this a little bit. Let's copy our pipe up here and plug these in. Whoops, I did not copy the whole thing. Copy that, delete this. This is our geometry, and let's look at this. Let's make the max here 0.1. Make these a little bit smaller. Hide all of that. Copy these previews. Green. How that works. So the surface that these lines make is called a hyperboloid, and so let's go ahead and just make that surface. You could just put all of these lines in a loft component, but for this particular surface, there's something we can do a little bit different to make the surface look a little bit better. It's basically just a manual way of choosing a specific loft option, but we can make a little component and then we'll use it on the next surface that we make also. So I'm going to get a curve component. And these lines are going to go into our curve component. Let's hide that. And let's test the length of this list. So I type in length, and let's type in list too, just so we can get this component called list length. And what we're going to do is make a bunch of lists that are just 2 items long. We're going to go from 0 to 1, and then 1 to 2, and then 2 to 3, and then 3 to 4. And that way we can grab just 2 of these lines at a time. So it sounds complicated, but it's really easy. We'll just get a series component. We'll count up however many items there are in this list. Then we're going to graph those. May as well simplify it while we're at it. And then we'll get another series component. All of these are going to be where our next, oops, I flattened to not graph. I graphed it. All of these are going to be where our next lists are going to start. And so if I double click and get a panel, and we put a 2 into the count of this second series, then you can see I have a list of lists, basically. I have one going from 0 to 1, one going from 1 to 2, one going from 2 to 3, and so on, all the way up until the last line in these lists. So these are going to be our index numbers. Let's type in list item, and we're going to use this component to grab all of these curves, put them in their own little branches. Let's hide all of this. And then we can say loft. And then if you want just one single geometry, we'll type in brep join. This is going to join all these surfaces into one brep, one brep. Then we'll say output to get a cluster output component. And then let's put all of this into its own component. And we'll just call it make surface. And here's a mistake I just made that I noticed while editing this video. If we double click on this component, we can go back inside and you can see that there's a tree coming in here. And so since there are separate branches coming in, this brep join isn't going to do anything. It's going to treat each individual brep separately, but we need all of these branches to be, instead of separate lists, we need it to be just one list. Because this component takes in a list and it joins everything inside that list. Right now, every list only has one item, but if we right click here and say flatten, then every item goes into the same list, and then the brep join will join all those breps together. So then we can click save, and we've fixed our component. Okay, back to the tutorial. So this kind of geometry might remind you of Antoni Gaudi because he's famous for this, and another geometry very similar to this called a catenoid. This can be mistaken for a catenoid surface. Catenary curves are one thing Antoni Gaudi is particularly famous for. Hanging chains and noticing the curvature that they make just due to gravity, and then using that geometry to, for example, design arches that have very low moment force due to the curvature of the arches. And catenoid surfaces are also minimal surfaces, meaning that they have zero mean curvature no matter where you look on the surface. just to see the difference, let's make one of those quickly. Let's just start with a point. I'll say construct point. And I'm going to get a vector component and borrow this vector that we made up here, these two vectors actually. So I'll just plug this in here, and then I'm going to go to wire display hidden and bring this down here. And let's move this point in the same two directions that we moved the circles. So now we have a point there and a point there. And let's move both of these points again in the z direction. So I type z and get unit z. And then let's get a slider between 0.000 and 2. Let's get a sphere just so we can see these, because right now there's a surface in our way. That's too big. Let's get let's say 0.03. So now we can see our points back there, so we can hide all of this. Let's hide this one too. So to make a catenary curve is very easy in Grasshopper. Just type in catenary, and let's dispatch these points. Plug in A and B. Let's move this up a little bit. One more thing we need for this catenary component is a length. Right now, let's get the distance between, what is the distance between these 2 points? And then let's multiply that by some factor greater than 1, just so it needs to be longer than the distance between these two, because if it's just the distance between these two, obviously we're just going to have a straight line between them. But what we want is something that hangs between these two. So I'm going to get a number slider between 1.000 and like 4. Plug that in. So you can see now it's a straight line. If we go like this, then it hangs. And you can see this curve is a little bit different than the hyperboloid curve here, the hyperbola. So let's hide all of this, and let's make a surface out of this catenary curve. So I'll hide that. I'm going to get a curve component. We'll call this catenary. Wire display hidden. Let's bring this down here, and let's say rotate. Let's rotate it around the YZ axis, the YZ plane. So that's going to be our plane. This is going to be our geometry that we're rotating. Then let's get a range. We want to rotate it all the way around in a circle. So we need to construct a domain between 0, which is the default for A, and 2 pi. So I'll type in 2, and I'll get a pi component. 2 pi is one time around a circle. So that's going to be our domain. And then the number is how many segments do we want as we go around that full rotation. So say maybe 10 less than 100. And I'm going to say call index, and I'm going to call the first index 0, because if I hover over this, you can see we're going from 0 all the way to 2 pi. 2 pi and 0 are equal here, they're the same, and that would give us duplicates of this catenary curve. We don't need that. So let's go back into perspective, and now you can see all of these curves. And let's just use that same component that we used up here, or that we just made, this component we called make surface. Let's use it down here for all of our rotated geometry. Flatten that just in case, hide it. Now we have a slightly different surface. So again, Antoni Gaudi used both of these geometries extensively in his designs to make shapes and to carve shapes and to do different kinds of experimentation too. If you're interested in Antoni Gaudi and the math behind his design, how his designs relate to nature, I would recommend looking into the work of Mark Burry and Jane Burry too. They've done an amazing amount of work, both preserving Antoni Gaudi's work, pushing forward unfinished work, and also articulating conceptually and mathematically what the work is about, how it was derived. So definitely check out their work. And thanks so much for watching this tutorial. And again, please do like and subscribe. These small gestures make a big difference. See you soon on the next one.